Next, the cost of 4 kg onion, 3 kg wheat and 2 kg rice is 60. The cost of 2 kg onion, 4 kg wheat and 6 kg rice is rupees 90. The cost of 6 kg onion, 2 kg wheat and 3 kg rice is rupees 70. Find the cost of each item per kg by matrix method. So the question is given in verbal form. So this verbal statement we need to convert in form of equations. The verbal form of the question must be converted in system of equations. So in the solution we will consider the cost of onion as x, the cost of wheat as y and the cost of rice as z. So 4 kg onion will be 4x, cost of 3 kg wheat will be 3y and cost of 2 kg rice will be 2z. So on adding all the three prices, the amount equals to 60. So the first equation will be 4x plus 3y plus 2z is equal to 60. Similarly, the cost of 2 kg onion is 2x plus cost of 4 kg wheat is 4y and the cost of 6 kg rice is 6z, which equals rupees 90. Similarly, we get the third equation for 6 kg onion, 2 kg wheat and 3 kg rice, which is equal to 70. So further again we need to continue the procedure of matrix method. We need to convert the system of equations into three matrices. So matrix A will be equal to 4 3 2 2 4 6 6 2 3. Matrix X will be equal to X Y Z and matrix B will be equal to 60 90 and 70. So first we need to calculate the determinant of A. So we are expanding the determinant using the first row. We get 0 plus 90 minus 40, which is equal to 50, and 50 is not equal to 0. Therefore the matrix A is a non-singular matrix and inverse of matrix A exists. Further, we will apply the formula of the matrix method. X is equal to A inverse B. So first we will calculate A inverse by obtaining the cofactors and adjoint. So A11 is obtained by deleting the first row first column, which equals 0. Next A12 is equal to 30. A13 is equal to minus 20. A21 is equal to minus 5. A22 is equal to 0. A23 is equal to 10. A31 is equal to 10. A32 is equal to minus 20 and A33 is equal to 10. So cofactor matrix is 0 30 minus 20 minus 5 0 10 10 minus 20 and 10. Next we will write the adjoint of the matrix, which is obtained by taking the transpose of the cofactor matrix. So we convert the rows into columns. So adjoint of A will be equal to 0 30 minus 20 minus 5 0 10 and 10 minus 20 and 10. So A inverse is 1 upon determinant of A into adjoint of A. So we get 1 upon 50 into adjoint of A. Finally we calculate the value of X. So X is a matrix consisting of the three unknown variables. A inverse we have calculated and B is already given 60, 10, 90 and 70. So on simplifying the two matrices, we get 1 upon 50 into 250, 400, 400. So on simplifying, we get 588. So X value is equal to 5, Y value is equal to 8 and Z value is equal to 8. So the cost of per kg onion, wheat and rice are 5, 8 and 8. Next, another verbal example. The sum of three numbers is x. If we multiply third number by 3 and add second number to it, we get 11. By adding first and third number, we get double of the second number. Represent it algebraically and find the numbers using matrix method. So, consider the three numbers as x, y and z. So according to the first sentence of the question, we have x plus y plus z is equal to 6. Next, if we multiply third number by 3, that is 3z, and add it to the second number, that is y, we get 11. So the equation will be y plus 3z equal to 11. And the third equation is adding first and third number, we get double of second number, that is x plus z is equal to 2y, or we can write it in the standard form as x minus 2y plus z equal to 0. So we have obtained the system of linear equation. Now we will be converting the three equations into matrices. So matrix A will be 1 1 1 0 1 3 1 minus 2 1. Matrix X is consisting of unknown variables and matrix B is consisting of the constants 6 11 and 0. So first we will calculate the determinant of A by expanding using the first row. So the value of determinant of A will be equal to 9, which is not equal to 0. So that matrix A is a non-singular matrix. Next, we'll be calculating X, which equals A inverse B. So first we are simplifying and obtaining the value of A inverse. So A11 will be equal to 7, A12 will be equal to 3, A13 is minus 1, A21 is minus 3, A22 is 0, A23 is 3, A31 is 2, A32 is minus 3 and A33 is equal to 1. So we have obtained the cofactor of each element of matrix A. So the cofactor matrix will be 7, 3 minus 1, minus 3, 0, 3, 2 minus 3 and 1. Next we will calculate the adjoint. So adjoint is the transpose of the cofactor matrix. We get A inverse is equal to 1 upon determinant of A into adjoint of A. So substitute the value of determinant of A and adjoint of A. Finally we calculate X, which equals A inverse B. So 1 upon 9 into 7 minus 3 2, 3 0 minus 3, minus 1 3 1, and the matrix B is 6 11 and 0. So first we multiply the two matrices. Keep 1 by 9 as it is and multiply the two matrices. So on multiplying, we get 1 upon 9 into 9, 18 and 27. So on simplifying, we get x is equal to 1, y is equal to 2 and z is equal to 3, which are the required three numbers. So the next concept we are understanding is consistent and inconsistent system of equations. Consistent system. A system of equation is said to be consistent if its solution exists, that is, if it has one or more than one solution. Next, inconsistent system. A system of equation is said to be inconsistent if its solution does not exist, that is, it is having no solution. So to check the consistency of the system of equations, we use the equation A into x is equal to b. So we have three cases here. If determinant of A is not equal to 0, then the given equations are consistent. Second, if determinant of A is equal to 0, then we find the product of adjoint of A into B. So if adjoint of A into B is equal to 0 matrix, then given equations are consistent. If adjoint of A into B is not equal to 0, then the given equations are inconsistent. So we'll consider an example. Examine the consistency of the system of equations x plus 2y equal to 2 and 2x plus 3y equal to 3. So write the given equations in form of matrices. So matrix A is equal to 1, 2, 2, 3. Matrix B is 2, 3. So calculate the determinant of matrix A. We get 3 minus 4, which is equal to minus 1, which is not equal to 0. So since determinant of A is not equal to 0, the matrix is non-singular and the given system of equation is consistent system because it will have a set of unique solutions. Next, examine the consistency of the system of equations. So again, split the given equations into matrices A, B. So now calculate the value of determinant of A. We get 4A minus 3A, which is equal to A, and A is not equal to 0. So inverse of a matrix exists and A is a non-singular matrix. So again, the given system of equation is consistent. Next question. Consider the equations x plus 3y equal to 5, 2x plus 6y is equal to 8. The matrix A is 1, 3, 2, 6 and the matrix B is 5, 8. Determinant of matrix A is 6 minus 6, which is equal to 0. So determinant of A is equal to 0. Next we need to calculate the adjoint of matrix A. So the adjoint of matrix A will be the matrix 6 minus 2 minus 3 1 and the transpose of that. So into B it is 5 8. So we need to multiply the two matrices 6 minus 3 minus 2 1 5 8. So on simplifying we get 6 minus 2, which is not equal to a 0 matrix. So the solution of the given system of equations does not exist. Hence the given system of equation is a inconsistent system. Next, examine the consistency of system of equations. So again, split the equations into matrices. Calculate the determinant of A. So determinant of A is equal to 51, which is not equal to 0. Therefore, A is non-singular and the system of equations is a consistent system. Next, if A, B, C are in AP, find the value of 2y plus 4, 5y plus 7, 8y plus A, 3y plus 5, 6y plus 8, 9y plus B, 4y plus 6, 7y plus 9 and 10y plus C. So we need to find the value of this determinant if A, B, C are in AP. So applying the operation we get So we can see the first equation over there, 2y plus 4 plus 4y plus 6 minus 2 into 3y plus 5, which is equal to 6y plus 10 minus 6y minus 10 is equal to 0. Similarly, the second equation is also equal to 0, and in case of third equation we are getting 8y plus a plus 10y plus c minus 2 into 4y plus b, which is equal to 18y plus a plus c minus 18y minus 2b. So here 2b, which is equal to a plus c minus a plus c, which is equal to 0. So the R1 elements will be 0, 0, 0, and there will be no change in the elements of R2 and R3. So since the elements of one particular row are 0, the value of the determinant will be 0. Next question, prove that delta equal to a plus bx, c plus dx, p plus qx, ax plus b, cx plus d, px plus q, u v w is equal to 1 minus x square into the matrix A C P B D Q U V W. So we'll consider the LHS and apply the property R1 implies R1 minus X into R2. So the first element of R1 is A plus Bx, and the first element of R2 is Ax plus B. So on simplifying we get A into 1 minus X square. Similarly, second element of R1 minus second element of R2, we get C into 1 minus X square, and third element of R1 minus X into third element of R2, we get P into 1 minus X square. Next, we'll substitute the new values of the elements of R1 and take out 1 minus X square common. So 1 minus X square is common. Next, we will apply the operation R2 implies R2 minus X R1 on the elements of R2. So on simplifying, the first element of R2 minus X into first element of R1, we get B. Similarly, when we simplify the second element of R2 and R1, we get D, and third element minus third element, we get Q. So the values of the second row will be BDQ. So on simplifying and substituting the new values of R2, we get delta equal to 1 minus X square into ACP BDQ UVW, which is the required RHS.